Greetings of the day. I'm Rajkumar Parashari and I love doing physics. Today I'm here with the detailed solution of question number 4 of Z Advanced 2020. I expect that you have read this question several times. Here is a charged capacitor connected to a circular loop through a key. This circular loop has n number of turns and its radius is capital R. Magnetic field B naught lies in the plane of the circular loop. Now let us see what happens when the key is closed. When key is closed, then first thing is capacitor starts discharging through the resistance offered by the coil. Electric current decreases exponentially as shown by this graph. This capacitor is get mostly discharged during the time interval 0 to capital T. This is 0 and this is somewhere is capital T. Point number 2. Current is flowing through this loop and hence it acquires magnetic moment. The value of magnetic moment will be given by NIA. If you want, you can write Ni into pi r square. Now you should be very clear about two things. Point number 1, this magnetic moment is a vector physical quantity and the direction of magnetic moment can be obtained by right hand thumb rule, and which it suggests that the magnetic field is coming normally outwards. Now because it's coming normally outward, and that is why we expect that the angle between the magnetic field and the area vector is 90 degree initially. Second point, that you should be very clear that bit time current is decreasing. Now as the current decreases, magnetic moment also decreases bit time. Now point number 3, here is a current carrying loop inside magnetic field and hence it should experience net torque, and the value of net torque you see is given by the expression mb sine theta. According to the problem, current flows for a very short period of time, and within this time period the coil, the circular loop has hardly rotated. So what we expect is that during this time period the angle roughly remains 90 degree, and hence this can be rewritten as the value of m is equals to n I depends upon time, into a is pi r square, and this magnetic field is b naught, and this is sine 90. So this can be rewritten as n into pi r square, b naught is to I. This is tau net at time t. Next part, the direction of torque can be obtained using the relation m cross b. Now you see the m vector is coming normally outside the board. This is m vector, and b naught is along axis of x. Let's assume this direction to be the axis of y and this to be along axis of z. So the m cross b suggests the direction of torque should be along axis of y, and this circular coil acquires tendency to rotate in anti-clockwise sense. Now point number 4, this torque provides the necessary angular impulse given by the expression delta L is equals to tau net dt integral from 0 to t. So L final minus L initial is equals to tau net is equals to mb dt from 0 to t. Substitute value of m. This is equals to n is to pi r square b naught I at time t dt, and this should be integrated from 0 to capital T, and this is equals to n pi r square b naught integral I at time t dt 0 to t, and this happens to the charge that flows during the time interval capacitor discharges, and hence this is equals to n pi r square b naught into q. Initially, the circular coil was at rest, and hence L initial is equals to 0. So the final angular momentum should be given by this expression, and hence let's check the choices. So it appears the B option is correct.